So we'll first we'll make it off first, and then we'll switch on the power button. So initially a power cord is connected. The instrument carry out all self check item before it start initialize, and it will show you the boot logo, and then it will show you the screen. Now this was initially adjusted for channel 1. So now I'll do it for channel 2. So it will be easy for you to understand that how do we start a fresh one. Okay, now I am intentionally keeping this on the top side because I need to compensate the capacitor that we have discussed in the previous video, the functionality of the probe. Now once it will check and it will show you this screen, then you have to first push the utility function or utility button. Now when you press the utility function, now you have to select the adjust. So see, again I'm pressing the utility button. Now here see, at this side there are many options are there. Maybe anything can be selected. So here we have to first select this. See, you can vary this thing, or you can also vary from here also, from this knob, multi-purpose knob, right? So you have to first select the adjust in the left menu, and select the default in the right menu. So here default must be selected. So default, press this key again to execute, press any other key to quit. So the default attenuation coefficient set value of the probe in this thing. So you have to again press the default. So utility default, then we'll execute. So here you can see that channel 2 has appeared. Initially there were no channel 2. I hope you understood. Initially there were only channel 1 was there. Now both the channels are introduced. So channel 2 is introduced, and by default we have to first make this in a, this is 1x position, this is 10x position. So we have to make in a 10x position, and then we have to connect in a, after connecting the probe or BNC connector, we have to connect this thing with the inbuilt 5 volt, and this is our ground. So then we'll connect this thing here. But before that, what you have to do, we have to press auto set. But let's say we'll connect over here, and this must be connected with the ground. Even though you will not connect, but it is having the same identical chassis ground, that's why it is showing like this. Now you can see over here, now in this case for a channel 1, I'm changing the position of channel 1, so you will be able to see the channel 2, and I am reducing the, for channel 2 I am reducing the amplitude little bit. Now this is nothing but it is a 1 kilohertz frequency and 5 volt peak to peak value. This is 5 volt peak to peak value and 1 kilohertz frequency. So what you have to do here is first push the auto set button on the front panel. So this is auto set button. right? So that you have to push it, and once you'll push it, you'll have this kind of thing, and then you have to select the waveform here. Okay, now this is for uh, these two waveforms are there. So this is a square wave which is there, and here we have to see that whether it is channel 1 is connected or channel 2 is connected. So I'm removing channel 1 intentionally because I want to assure that it must be for channel 2. So uh, in order to do that, I'll go into the utility, then okay, I'll have to go into see, this will automatically go after 10 seconds. So I'll go into the channel 2. Now there is a coupling 10x, measurement is off, limit is there. Okay, now this, so the same what I have to do is I have to select the channel 2, right? So again, in a utility, function is there, keylock is there, device is there. In a function we have a adjust, and we have auto set. Okay, and then this must be selected. Okay, so okay, now this is correct. So what we have to do, we have to go into the utility, then function, and then we have to select the default, and now you can see this blue cursor is there. So now see, I'll try to reduce the amplitude little bit, and I don't know whether you are able to see over here or not. It is 500 microsecond. So one line contains one division contains 500 microsecond here. So total is 1 kilohertz frequency, 1 millisecond. So total is 1 kilohertz frequency. Now this thing is for 2 volt. Each division vertically is 2 volts, so it's totally 5 volt. Now here you can see that it's not exact square wave, and we need to have we need to compensate. So what I'll do, I'll insert this into the capacitor compensation, and I'll try to vary the value of the capacitor in capacitance. See, I'm increasing right now, so it is again deteriorating the waveform. Now I'm rotating in a anti-clockwise, so now you can see that it is, see, I'm increasing in a clockwise, so it is deteriorating in anti-clockwise. It is becoming perfect square wave. So you have to ensure that whenever there is a perfect square wave, you have to leave it. So this is what exactly the method of compensation of the capacitance. Now this is required to do for both the channels simultaneously, one by one, not simultaneously, one by one. So first you have to do it for channel 1, and then you have to do it for channel 2, right? Now I'll again introduce channel 1 because that process is already done for channel 1 also. Now here this process is completed, and that this process is called as a probe compensation process, and that has been completed. Now again we'll go into the this thing, a channel selection for to see that I mean, see, we have done it for this thing, a 10x case, but we can, if we try to do it with a 1x, this thing, this as a 1x, this switch as a 1x. Right now, I'll reduce this amplitude. Though it is compensated, but this compensation we have done it for 10x, right? So why we have done it in the mode of 10x? Only because this is very important to note, that only because when we do the attenuation switch in a 1x position, the probe will be compensated only for a specific range of the bandwidth, and that is for 5 megahertz only. So this 5 megahertz has nothing to do with the 5 megahertz of this function generator, but it is a functionality of this DSO itself. Otherwise, see, the full bandwidth of this DSO is 100 megahertz. So in order to make the utilization of the full bandwidth, we have to always compensate for introducing the more resistance into the probe. That was around in terms of 10 mega ohms, right? So it is desirable that this compensation must be done using the switch in the 10x mode. Now whenever you are operating this thing, you should be very much careful that you should not touch any of the part of the circuitry or this oscilloscope. It is always desirable that this acts as a tip, or you can say a safety guard ring, and it should be used in such a way that it protects you, right? So it can be, you should very well, I mean, you should not move your finger outside this area. This is just for the safety. Now we'll try to understand the process of self calibration. So okay, let me connect this signal over here. This is connected with the ground, and this is also okay. So okay, leave it. Now we'll go into the utility. Okay, we need to first see that what is the self calibration. So that's why I have gone into the utility, but right now you cannot see any waveform over here. The reason I'll tell you that why you cannot see any waveform, because this is at channel 2, coupling is AC, probe is 10x, ground DC, AC, and okay, the amplitude was very small, that's why you cannot see any waveform in that case. Okay, now you can see the waveform, that is the sine wave over here. Now both the channels are connected, channel 1 and channel 2. So we'll see that how to switch over, but before that let us understand the one more functionality of this utility button. Now here there is a function which is called as adjust, which can be, if you press this function button, then you can have this many options. Now right now we don't want to use any of the options over here, but in this there is a utility, there is a self cal is there. Now this self cal in the right menu, must be run when you're using this DSO for a long time, and let's say your ambient temperature increases above 5 degrees Celsius. Now in that case you have to again self calibrate this DSO in order to ensure that it should give you the proper readings. Otherwise it is not required to use it. So it is not desirable that you make a self calibration frequently. Apart from self calibration, there are other thing like default and probe channel is there. So that we'll see that later on. That default means it's a factory default this thing, and probe channel, that also we'll discuss in the functionality, that in the next, when we'll cover the utility in detail. Okay, now next is a coupling mode. So this is very important. So in the case of coupling mode, now this area you can see over here. So right now it is a AC coupling. Let's say if I'll press the CH2 channel and I'll see the coupling, then this is AC coupling. Now see, let us try to understand this, very important. See, in the case of AC coupling, in the case of see, I'll press again, then it's a ground, means it is directly grounded. DC means there is, you cannot see any signal right now, but as in AC it is a, again you have a signal. But sometimes what happens, that it is a AC plus DC signal is there. That means along with it's a DC leveled AC signal is there, right? Like I'll change the position over here. Let's say this is something like this. So this is nothing but this contains DC plus AC. Now in that case you cannot use AC coupling, because if you use AC coupling, then DC will be bypassed, and if you use DC coupling, then AC will be bypassed. So it is better that when you should be very cautious that what kind of signal is there. You should be aware about it, that whether it's only pure AC or DC contains AC plus DC, and there is a ground. So please do not, I'm repeating again, do not confuse yourself. In the case of coupling, AC means it's a pure AC signal, DC means it's a elevated one. So the ground means nothing. Now uh, see, if I'll again press the position, then it will automatically come into the its original grounded position, and I have to press this knob. I have to press this knob. Even if I'll change this and I'll press this, then automatically it will come into the reference position. Now we'll first try to understand the functionality of this vertical position. Functionality of vertical position. Now in the vertical position there is two knobs over here and two knobs are there. This is for channel 1, channel 2. These two are the buttons for channel 1, channel 2. This is for math. Forget about this thing math right now, because it contains lot many operations are there, like multiplication, division, subtraction, then divide by something. Even FFT can be done on the signal. So that we'll see in the later part. Now here the vertical position. See this vertical position. Now you can if you rotate this thing. Okay, let me go to the original one and remove the ground. Instead of ground I'll make it AC. So we have a signal. After 10 seconds it will or you can press this button and it will go. Now see, you can use this multi-purpose button to, let's say, have we have a right hand side, there is a menu, and if I'll press this thing, then it will be out of the screen. Now see, you can see both the signals, I think. Okay, great, because both the channels are connected. So now you can see the signal, because in that case I'll have a different voltage for different adjusted different voltage for this thing, for channel 1. Now in the vertical position, no positions the regulating of the vertical display positions. So by regulating the vertical display position, so in this case channel 1 is selected. If I'll select the channel 2, then I can regulate the vertical display position of this thing. Now similarly, uh, for horizontal position, there is a horizontal knob is there. So if I'll rotate this thing, then the horizontal position will be shifted. Okay, now as I've told you that there is a offset uh, scheme is there. I'll make it very small, right? So it would be easy for you to see this thing. Now let's say I have changed this thing to some another position, and now there is offset. Now I want to make it there is a short. How do I make to its reference position? So there is a short key. So if I press this thing, then automatically the waveform will come into the original position. Okay, now for horizontal already we have discussed, but in the horizontal, the you can see over here that there is a scale to change the frequency. I mean, we are not changing the frequency, actually the frequency is fixed, but just to uh, for a representation on the screen we are changing the frequency. I mean, this is minimized, and I mean we have increased the frequency, and this is reduce the frequency, right? But actual frequency is fixed, but just for the on the display we are changing the frequency position. Now how do we ensure that what at what position we are, right? So this you can see over here. From this you will be able to read that this is 500 microsecond step. Now if I'll change the knob position, I'm increasing 1 millisecond. This is 2 millisecond no position. This is 6 millisecond no position. So now I'm changing. Right now I'm again increasing 500, 200, 100 microsecond, 50 microsecond no position. Again I'm increasing the. So this position of the knob can be directly read from here, and this indicates sampling time. Right, now this will see in the detail that what is the depth. So depth is 10K. This is for when we take the data, at that time this depth comes into the picture, that how many datas and how many data will be there. Now for channel 1 it is a yellow, and for channel 2 it's a blue. For channel 1 it's a yellow, and for channel 2 it's a blue. So for channel 1 also, if you see on the screen, then you cannot see the yellow this thing, but you can able to see the blue one, right? So for yellow it is at 5 volt per division, that's why you cannot see. Now if I'll reduce it, then you can see that this yellow signal can be seen properly, right? So now in that case, now if you see, then it is 100 millivolt, and this one is so one sorry, 10 millivolt, not 100. I don't know whether I'm able to see it properly or not. 100 millivolt. One corresponds to 100 millivolt, and this for 50 millivolt. Blue is for one division is for 50 millivolt. Right now, here in the horizontal, if I press this thing, right, then you can see the two separate windows. So one is with zoom, and it's a switch between normal mode and the wave zoom mode. Now this is called as a wave zoom mode. So this two separate windows are there, and this is a normal window and this is a wave zoom window. Now you can see over here that at what factor it is being zoomed by factor 2.5x, right? So if you again press this thing horizontal, then again it will come into the normal mode, right?